Hi everyone, today we're going to be doing lesson 3.7b, day 1, where we're going to solve and graph absolute value inequalities. Um, Absolute value inequalities can get very confusing. I will be perfectly honest with you. We've practiced with our equations, and remember we set up two equations, one with our positive solution, one with our negative. The inequality is very similar, but they do get confusing. So we want to find values of x that can make this inequality true. Remember, absolute value represents a distance a number is from 0. And there's two sets of solutions. So here we want solutions where the absolute value of x is less than 5. So what are some numbers that could go in there? Well, 5 can't. It's not a solution. I'm going to put an open circle on there. But what about negative 4? The absolute value of negative 4 is 4. That's less than 5. Absolute value of negative 3 is 3. That's less than 5. Let's go over here. Absolute value of 5, that is 5. So that is not a solution because 5 isn't less than 5. But the absolute value of 4 is 4. That's less than 5. So as you can see, this would be my solution. X can be greater than negative 5 or less than positive 5. This is an and inequality, as you can see. And the way we can help remember that is when our absolute value has a less than, think of that as less than, and we can make sure that we bring it together. It's our Oreos and milk. We want this together. Our solutions will be between those. Okay, I forgot to clear my screen, but we'll do our next one. So what about absolute values, numbers greater than 7? Well, again, let's think of some solutions. Greater than or equal to. 7 is a solution because the absolute value of 7 is 7, and 7 is equal to 7. Is 6? If I put a 6 in here, is the absolute value of 6 greater than 7? No. But 8 is, 9 is, 10 is. All of these numbers have an absolute value that is greater than 7. Okay, what else could be in here? Well, what about negative 7? Absolute value negative 7 is 7. That is equal to, since we have the equal to there, that is a solution. What about negative 6? Absolute value of negative 6 is positive 6. That isn't bigger than 7. But negative 8 is, absolute value of negative 8 is 8. That's bigger than 7. Absolute value of negative 9 is 9. That's bigger than 7. So you can see this is one of our OR inequalities. All of our solutions for x have to be less than or equal to negative 7. Notice my sign is the other direction. Or greater than or equal to positive 7. So how can we remember that this is an OR inequality? Well, if it helps you, if our absolute value is on the left and we have a greater than sign, let's think of great OR. And then we know we have an OR situation. Okay, so now I have absolute value of 5x is greater than 20. I hear the word or, greater than 20. So we're going to sketch out some possibilities of what this entire value can be. It can be values that are greater than 20 or less than negative 20. Those would make this true. Now we're going to set up our inequalities and solve it. We know that our 5x, therefore, can be less than or equal to negative 20, or our 5x can be greater than or equal to positive 20. Divide both sides by 5. And x can be less than or equal to negative 4. Or divide by 5. X can be greater than or equal to 4. So if I graph that at 4, I'm going to have an closed circle, and we're doing numbers greater than 4. And at negative 4, I'm going to have a closed circle. I didn't label my 4 over here. I'll go back and do that. And it's going to be numbers less than negative 4. So the numbers in between here will not make it true, like 0. 5 times 0 is 0. Absolute value of 0 is 0. 0 isn't bigger than 20. But if I grabbed 5, 5 times 5 is 25. The absolute value of 25 is 25. That is true. That's bigger than 20. Or if I grab negative 5 times 5 is negative 25. The absolute value of negative 25 is 25. That is greater than 20. So I graphed it correctly. So this would be my final solution. Okay, let's look at another example. I have absolute value of x plus 6 is less than, make sure we hear that and in there, 8. So we know our possible solutions is x can be greater than negative 8, x plus 6 can be greater than or equal to negative 8, or less than or equal to positive 8. So if I were to write my inequality, I'm going to write my negative 8 on my left, my positive 8 on my right, my x plus 6 in the middle. Because this is an and, I can write one inequality. Less than or equal to, less than or equal to. Let's subtract 6 from both sides. Oh, not both sides, all 3. And I get negative 14. Less than or equal to x. Less than or equal to positive 2. So at negative 14, I would have a closed circle. Think about here is 2. If I counted right, I have a closed circle. And it's the numbers in between there that should all be solutions. Again, I like to grab easy numbers. So how about 0? If I grab a 0, 0 plus 6 is 6. The absolute value of 6 is less than 8. What if I grabbed one over here like this, negative 13? Negative 13 plus 6 is negative 7. The absolute value of negative 7 is positive 7. That is less than 8. These are my solutions. This is my final answer. Okay, I have a greater, so I'm going to have 2. But one thing I want to point out is I have other numbers over here along with the absolute value. We want to get that absolute value isolated first. So let's add 2 to both sides. So now we know the absolute value of 2x plus 5 is greater than 9. So again, we got an or. So our sketching order solutions, our numbers can be less than -9 or greater than +9. So 2x plus 5, as I just said, can be less than -9, or 2x plus 5 can be greater, I'm really emphasizing the or, than 9. Let's subtract 5 from both sides. I get 2x is less than -14. Divide by 2. And I get x is less than -7. So at -7, I lost my negative there a little bit, I'm going to have an open circle, and my numbers are less than -7. Now on this one, I'm going to subtract 5 from both sides again. And I get 2x is greater than 4. Divide both sides by 2. And x is greater than 2. So I'm going to have an open circle at 2. And my answers will go this way. So in this case, 0 shouldn't work. If I put a 0 here, 2 times 0 is 0, plus 5 is 5. The absolute value of 5 is 5, minus 2 is 3. That is not bigger than 7. But if I grab 3, 2 times 3 is 6. 6 plus 5 is 11. The absolute value of 11 is 11. Minus 2 is 9. 9 is larger than 7. So that works. Always good to test them out to make sure your pictures go the right direction. And this is my final answer. X is less than -7, or x is greater than 2. Okay, I have another less than. So I know I'm going to have one inequality, but first I want to get my absolute value isolated by multiplying both sides by 2. So the absolute value of 4 minus 2x is less than 6. So what are my possible solutions to this? Oops, I didn't mean to do that. I hit the clear screen. My value of 4 minus 2x can be greater than -6, or my 4 minus 2x can be less than +6. So I'm going to write my inequality. I have -6 less than 4 minus 2x. Less than +6. Let's subtract 4 from all parts. I didn't say both sides that time. And here I have -10. In the middle, I have -2x. And on the left side, I have +2. So now I need to divide everything by -2. My pencil's being a little slow. Divide by -2. Divide by -2. Because I'm dividing by a negative, I need to flip my inequality. I have a positive 5 here, greater than x, greater than 2 divided by -2 is -1. Well, now my arrows are pointing the wrong direction, and my smaller number is on the left, so let's rewrite it. -1 less than x less than 5. And if I were to graph this, I kind of wrote over it. Maybe I'll just make a new number line up here. Then I don't have to worry about counting my spaces either. At -1, I would have an open circle, and my numbers would go this direction. At 5, I would have an open circle, and my numbers would go this direction. So this is my solution and graph for this inequality. Okay, when I first read this question, I have to tell you, I was a little bit confused about how to teach this in relation to this unit. It says we get student scores on an algebra exam that range from 60. I'm going to put 60 on here. I'm going to count by fives. 65, 70, 75, 80, 85, 90, 95, 100. I'm going to put 100 here. So it said they range from 60 to 100. So that means we had students that had 60, and we had students who had 100, and we had all scores. I'm not even sure that's where that was, if it's here. We had all scores in between. So, yeah, my dot should have been here. We're going to move it. We're going to ignore this because I don't like that. So, when I look at that, I know that my inequality would be x is greater than, well, I don't want to do it that way. I want to write it as a compound inequality. 60 is less than or equal to x is less than or equal to 100. But now let's look at what this is showing us. We're seeing these 80s, these 20s. What's going on? Well, 80 right here is in the middle. 65, 70, 75, 80 is right here between the 60 and 100. And all of the scores are within 20 points of 80 on both sides. So we should take any score we have. It should be within 20 points of 80. Could be less than or equal to 20 points or 80. Couldn't be more than 20 points away from 80. So let's take a look to see which of these absolute values work. If I were to solve each of these, which one would give me something like this? Well, we get less thans. So we're going to do one equation. I can have -20 is less than or equal to e minus 80. I used x. E is what they use. Is less than or equal to +20. And you'll see that when I add 80 to all parts, that I'm going to get exactly what I want to have. I end up with -20 plus 80 is 60. Is less than or equal to e. And that's less than or equal to 100. So that works. And sometimes solving them and comparing to what you know is the easiest way to look at these. What if I had solved this one instead? I would have had negative 80 less than or equal to e minus 20. Less than or equal to positive 80. And the right side, when I add my 20, will give me the correct upper limit of 100. But you'll notice that if I add 20 to the left side, I end up with negative 60. And that is not within my range. X is not greater than or equal to negative 60. So this one didn't work. I run into similar problems with these two. If I did negative 20 and e plus 80, and positive 20, I immediately see that I have issues. When I subtract 80 from all of the sides, I'm ending up with negative 100, which is not an answer I like. And on this side, I end up with negative 60. My range of numbers are not negative 100 to negative 60. So this doesn't work. And this one, very similar to the other one when I have my negative 80. When I subtract my 20 from that, I'm going to get negative 100. So again, I'm going to have issues. I'm going to end up with a positive 60 this time on the left, but I'm still going to have a negative 100. This is very messy, I know. But as soon as I start seeing those negative numbers, like negative 100, that is not in my range of scores. So they won't work. So you could have, thought about this and said, oh, well, the distance that my score is from 80 has to be less than 20. But solve it if you need to. There's nothing wrong with that. And you're more likely to end up with the correct answer because sometimes just looking at these, they can look right. But until you actually go in and solve them, you'll run into problems. So that is our correct answer. So let's do a quick little summary. First of all, we need to get our absolute value isolated. We need to get it by itself. After that, if it's a great or, we're going to pull it apart and set up two inequalities. If it's a less than, we're going to put it together and have one inequality, the negative solution on the left and the positive on the right. Then we're going to solve and graph. That's it. Have a great day.